This is a case study type of question on physics based on electrostatics. The electric field inside the cavity is zero. Whatever be the size and shape of the cavity and whatever be the charge on the conductor and the external fields in which it might be placed, the electric field inside a charged spherical shell is zero, but the vanishing of electric field in the charge-free cavity of the conductor is, as mentioned above, a very general result. A related result is that even if the conductor is charged or charges are induced on a neutral conductor by an external field, all charges reside only on the outer surface of the conductor with cavity. The proofs of the result is noted in the figure are omitted here, but B, note their important implications. Whatever be the charge and their field configuration outside, any cavity in a conductor remains shielded from outside electrical influence. The field inside the cavity is always zero. This is known as electrostatic shielding. This effect can be made use of in protecting sensitive instruments from outside electrical influence. Now, based on this paragraph, we are going to, these questions are asked. First question, the metallic shell having inner radius R1 and outer radius R2 has a point charge Q kept inside the cavity. Electric field in the region R1 lesser than R lesser than R2, where R is the distance from the center is given by A, depends on the value of R, B, 0, C, constant and non-zero everywhere, none of the above. So basically the diagram goes this way. Now from the paragraph it is clear that the electric field inside the cavity is zero. So option D is the correct answer. Second question, the electric field inside the cavity depends on the size of the cavity, shape of the cavity, constant and non-zero everywhere. D, none of the above. So in the same paragraph we can see that the electric field inside the cavity is zero, whatever be the size and shape of the cavity and whatever be the charge on the conductor. So it should be, it doesn't depend upon the size, it doesn't depend upon the shape, and it is constant and non-zero. Can't be that option 2. So option D is correct, none of the above. Electrostatic shielding is based A, electric field inside the cavity of a conductor is less than 0. Electric field inside the cavity of a conductor is 0. Electric field inside the cavity of a conductor is greater than 0. Electric field inside the cavity of a plastic is 0. So from the above paragraph, we can see that the whatever be the charge and the field configuration outside, any cavity in a conductor remains shielded from the outside electrical influence. The field inside the cavity is always 0. So this is known as electrostatic shielding. Obviously, we can see that B is the correct option. Electric field inside the cavity. So electrostatic shielding is based on the electric field inside the cavity of a conductor is 0. So option B is correct. During the lightning thunderstorm, it is advised to stay inside the car. B, under trees. C, in open ground. D, on the car. Now, in thunderstorms accompanied by lightning, it is always safer to be inside a car or a bus than to be on open ground on a tree, because the metallic body of the car or bus provides the electrostatic shielding from the lightning. So the fundamental fact that the electric field inside a cavity is 0 can be applied here. So it is always safe to be inside the car. So option A is correct. Now coming to the fifth question, which of the following material can be used to make a Faraday cage based on electrostatic shielding? A, plastic, B, glass, C, copper, D, wood. Obviously, the Faraday cage should be made of a material which is of metal. So of the options, you can see copper is the only material which is a metal. So option C is correct.